galvanometer as ammeter. Whatever the galvanometer we have here, we know that it is able to detect the presence of current, but it is not able to measure the current. That is our problem. Let us say, usually galvanometer is shown like this, a circle with a G inside. And if it is A, it is going to be ammeter. If it is B, it is going to be a voltmeter whenever you use. Because it has got n number of turns, it will have some resistance. Let us say Rg, that is the resistance of galvanometer. So it was actually a single device, but I have split it into two components. One is the instrument which is measuring, and the other one is the resistance. Now, what is the problem with this galvanometer is, it is a very sensitive device. We know that there is a galvanometer which is the measuring instrument, and because of this windings in the coil, there will be a resistance Rg. Can we reduce the amount of current which we are making it to flow in this galvanometer? Yes. How we are going to do it? When we have a circuit, if we want to use an ammeter, we will use that ammeter in series with the circuit. Remember this word, it is a Viva question in your lab exam. How we are going to use the ammeter? Ammeter is used in series with the circuit. Voltmeter is used in parallel with the circuit. Have this galvanometer, it is supposed to be connected in series with the circuit. Let us say there is a huge circuit, and in between we are going to put this galvanometer into that circuit. As soon as this galvanometer will be connected, a large amount of current is going to flow through the galvanometer, and this pointer is going to go out of scale. What we are going to do? What we need to do is to reduce the amount of current which is passing through this galvanometer. How we are going to do? Can we make the current to go through alternate route? Yes. We are going to make an alternate path for the current which is having a very small resistance. We are going to call it as RSH, and this is called as shunt resistance. It is called as shunt resistance. So the circuit, the current was coming and the current is supposed to leave. Let's say this is the current, this is the current. When it comes to this point, this resistance is very small. So the maximum amount of current flows through the shunt and comes back and completes the circuit. But what flows through the galvanometer is very small amount of current which goes through the galvanometer. And by choosing the correct appropriate value of that shunt resistance, we can make this galvanometer to measure at least approximately the amount of current that is flowing in this circuit. It will not be, we will try to make it as appropriate as possible, but it is not always exact. So when we connect this shunt resistance, shunt, it is another word or the technical word for parallel. It's not a new word. Already we have seen the parallel resistances. So shunt is just a technical word for the word parallel. So shunt is going to be a parallel because this resistance is connected in parallel with the galvanometer. It is called as shunt resistance, and it will be a very small value of resistance. Another Viva question here. How to convert galvanometer into ammeter? The answer for this question is by connecting a very small value of resistance in parallel with the galvanometer. In parallel with the galvanometer. The previous statements what I said, they were different. These statements will be different. Initially I said the ammeter will be connected in series with the circuit. If I convert the galvanometer into ammeter, the resistance is connected in parallel with the galvanometer. Remember all the words of that statement. Parallel with the galvanometer. Previous statement was series with the circuit. So please don't mess up the words. So here if I connect a small resistance in parallel with the galvanometer, then this galvanometer will behave as an ammeter. Galvanometer into voltmeter. So we already have our instrument with its resistance Rg. So we have this galvanometer which is measuring, and because of the coils there is a resistance Rg. And in this, if I want to convert, it will be just exact opposite of what we did for the previous case. In the ammeter, we connected a small resistance in parallel. Now, we'll do the exact opposite thing. We are going to connect a large resistance, but not in parallel, in series. And this one will be called as RS, that is series resistance. Now, again, if I do the calculation, they are in series, R should be equal to Rg plus Rs, because when we come to the lab, you will realize that this Rg value will be in the range of 80 to 120 ohms, and this resistance Rs, which we will be calculating for implementation in the lab, it will be coming in the range of 4000 to 8000 ohms. It is a very large value compared to 100 ohms which is present with Rg. So what we are going to write here is it will be Rs nearly equal to Rg plus Rs, because it is in the range of 5000, 4000 or even 8000, and this is like 70, 80 or 100. So this will be the equation for the galvanometer as voltmeter. Now what will be the explanation? To convert a galvanometer into voltmeter, we connect a large resistance Rs in series with the galvanometer, and that large resistance is going to reduce the amount of current which flows into that path. In the same path, when the current flows, the current was supposed to flow in the galvanometer, but the galvanometer resistance was less. It was only in the range of 100. So the current flowing in the galvanometer would be large, the deflection would be large. So what we are doing here is, by using this Rs, we are reducing the amount of current that is going to flow through the galvanometer. So the galvanometer will be able to measure that small value of current, because we have Ohm's law, V is equal to IR, and this is going to become IRS. That is the series resistance. The current flowing, it can be measured by the galvanometer. When multiplied by this Rs, it is going to give us the value of the voltage.